Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on the volume of a prism. If you need any extra help in this topic, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 356, there's a dedicated video tutorial there on finding the volume of a prism. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so let's have a look at our first question, question number 1. So question number 1 says, shown below is a cuboid. So we've got this cuboid, and we've been asked to find the volume of the cuboid and to include units. So in this worksheet, we're going to be looking at how to find the volume of prisms, such as triangular prisms and things like that, where we're going to be finding the area of the cross-section and then multiplying by the length for the height. But also remember that a cuboid is a prism as well. And you've probably already looked at how to find the volume of a cuboid, where you would do the length times the width times the height. So if I was asked to find the volume of this cuboid, I would just do the volume is equal to the length multiplied by the width multiplied by the height. And if you do the length times the width times the height, you'll get the volume of the cuboid. So let's do that to begin with. So the length is equal to 9. We're going to multiply that by the width, which is 3. And we're going to times that by the height, which is 2. So we'll do 9 times 3, that's equal to 27, times 2 is equal to 54. So it means the volume of this cuboid is 54 centimeters cubed. And that's it, that's the volume of that cuboid, 54 centimeters cubed. Now I just want to also mention that in this video we're going to be looking at how to find the volume of a prism, and to find the volume of a prism we'll be finding the area of the cross section and then timesing it by the length of the prism. So here, if we were to work out the area of the front of the cuboid, we would do 9 times 2, that's the height, 9 times 2, and 9 times 2 is equal to 18, and then if we times it by the length of the cuboid, and then in this case that would be 3, and if we do 18 times 3, that's equal to 54 as well. So you could use that approach where you get the area of the cross section and times by the length, but if it's a cuboid, I just did the length times the width times the height, and that'll give you the volume of the cuboid. Okay, let's have a look at our next question, question number 2. Okay, question number 2. Question number 2 says shown below is a cube. So we've got this cube, and we've been asked to find the volume of the cube and to include units. So again, we could get the area of the front of the prism. So here we could do 5 times 5 to get the area of the front of the cube, which would be 25 centimeters squared, and then times by the length, so times by another 5. But if it's a cube, I would just tend to do the volume is equal to the length times the width times the height, which would just be, in this case, 5 times 5 times 5, which is the same thing really anyway. 5 times 5 is equal to 25, times 5 is equal to 125 centimeters cubed. So that's the volume of that cube, 125 centimeters cubed, and the units are centimeters cubed. And that's it. So to get the volume of a cube, you just do the length times the width times the height, and because it's a cube, they'll all be the same value. So here it'll just be 5 times 5 times 5, and 5 times 5 is equal to 25. And if you need to do 25 times 5, you could just do it to the side and do 25 times 5 by doing 5 times 5 is equal to 25. Put a 5 down and carry over 2. And 5 times 2 is 10, plus 2 is 12. So you can just do the method if you need to. I knew that 5 times 5 times 5 was 125 because it's a cube number. 5 cubed is 125. Okay, let's look at our next question, question number 2. Okay, question number 2. So we've got onto these nice triangular prisms. So I really like these questions here, where it says shown below is a triangular prism. So we've got this triangular prism, and we've been asked to find the volume of this triangular prism. So to find the volume of a triangular prism like this, we want to get the area of the cross section. So if you have a look at this, we've got this triangular prism. If you chop it down vertically here, every time you chop it down, you'd have this identical, this congruent triangle, this identical triangle the whole way down through this prism if you cut it anywhere vertically down this way. So we want to find the area of this cross section, so the area of this triangle at the front. And if we find the area of this triangle at the front, that'll be the area of the cross section of the prism, and then you just need to times it by 12, the length of the prism. So let's find the area of this triangle. To find the area of a triangle, you do the base times the height divided by 2, or half the base times the height. So the area of the cross section, area of the cross section, or the cross sectional area you may see, is the area of this triangle. So we would do half the base times the height. That's how you find the area of a triangle, half the base times the height. Now you could do the base times the height and then half it. You could do half the base and then times by the height. You could do half the height and then times by the base. I'm just going to do the base times the height first of all, so I'm going to do a half of. And 5 times 4 is equal to 20. And then we're going to half it, so half of 20 is equal to 10. So that'll be 10 centimeters squared. So the area of this triangle will be 10 centimeters squared. And it's very important you know how to find the area of a triangle if you want to find the volume of a prism. So know how to find that area of that triangle. So you do the base times the height and then half it, or half the base times the height, or half the height times the base, but making sure you're just half them once. So the area of this triangle, the cross section, is 10 centimeters squared. If we want to find the volume, we're now just going to do that area multiplied by the length of the prism. So we're going to do 10 times 12. So 10 times 12 is equal to 120. So the volume of this prism would be 120 centimeters cubed, and that's it. So we just times that cross-sectional area, which was 10, by the length of the prism, which is 12, and 10 times 12 is 120 centimeters cubed, and that's it. Okay, let's look at our next question, question number 4. So question number 4 says, shown below is a prism. So we've got this pentagonal prism because we've got this pentagon at the front, and then it's a prism. So it's a pentagonal prism, and the cross section here is shaded. It's shaded in green because if you chop it down anywhere vertically, you would get that identical pentagon. You'd get that congruent pentagon. And it says the cross-sectional area is 21 centimeters squared. So it's quite nice. It's told us the area of this cross section, the area of this green region, to be 21 centimeters squared. And then we're told the prism has got a length of 6 centimeters. I've been asked to find the volume of the prism. Well, actually, this question is really, really nice because we know the cross-sectional area. So to find the volume, we just need to take the cross-sectional area, which is 21, and times it by the length of the prism, which is 6. So we just need to do 21 times 6, and that'll be the volume. So it's already worked out that area for us. Quite often we have to work out that area, like in the last question, but this time it's been given to us. So we just need to do 21 times 6. Now it's a non-calculator question, so 6 times 1 is 6, and 6 times 2 is 12. So the answer would be 126 centimeters cubed. So that's the volume of that pentagonal prism. So the volume of that prism is 126 centimeters cubed. Okay, let's look at our next question, question number 5. Okay, question number 5. So question number 5 says the diagram shows a trapezoid prism. So it's a trapezoid prism. We've got this trapezium and it's a prism. So it's a trapezoid prism. And we're told the area of the cross section, so the shaded area, is 55 centimeters squared. So the area of this face here is 55 centimeters squared. And the volume of the whole prism is 330 centimeters cubed. And we've been asked to find the length of the prism. So we want to find the length of the prism. So if we wanted to find the volume, we would take the cross-sectional area, which is 55, you would times that by this length, you would times it by whatever the length is, and we would get an answer of 330. So we just need to figure out what they've multiplied the 55 by to get 330, and that'll be the length of the prism. So let's see how many 55s go into 330. Now it's a non-calculator question, so that means that I'm thinking it's going to be quite a nice number. So let's write down the multiples of 55. So they would be 55, add another 55 would be 110, add another 55 would be 165, add another 55 would be 220, add another 55 would be 275, and again, if you need to do any of these additions, you could do it on the page here. Add another 55 would be 330. So that's fantastic. It's 1, 2, 3, 4, 5, 6. So 55 times 6 is equal to 330. So that means that this length here must be 6 centimeters. So the length of the prism is 6 centimeters. And that's it. Okay, let's look at our next question, question number 6. So question number 6, we've been given a diagram of a prism. So we've got this prism, this L-shaped prism, and we've been asked to work out the volume of the prism. So we want to find the area of the cross section. So the cross section is this L shape here. I'm just going to highlight it here. So this is what we want to find the area of. That's the cross section. So we want to find the area of the cross section, and then we're just going to times it by 10, the length of the prism. So let's find the area of this shape here. So I'm going to divide it. I'm going to split it into 2 rectangles. So here we've got a smaller rectangle here that is 5 centimeters by, and then if we have a look here, we've got 3, so that'll be 3 there. So this part's going to be 5 times 3. This area is going to be 5 times 3, which is 15. So 5 times 3 is equal to 15 centimeters squared. So that's fantastic. This area is 15 centimeters squared. Now we want to find this area. The height of this rectangle is 8 centimeters, but we want to know this measurement here because we need to do 8 times the width to get the area of this rectangle. Now the whole shape has got a width here of 9 centimeters, and this is 5. So that means that this part must be 4 centimeters up there because 4 plus 5 must be equal to 9. And 8 times 4 is equal to 32 centimeters squared. So that means the area of this part of the shape, this rectangle here, would be 32 centimeters squared. So that means the whole front of the shape, the whole cross section here, has an area of 32 plus 15 is equal to 47 centimeters squared. So that's the area of the cross section, 47 centimeters squared. Now we've been asked to find the volume of the prism. So to find the volume, we take the area of the cross section, which is 47, and you times it by the length of the prism, which is 10. So 47 times 10 is equal to 470 centimeters cubed. So that's the volume of the prism, 470 centimeters cubed, and that's it. So let's write that down, 470 centimeters cubed. Okay, let's look at our next question. Question number 7. So question number 7 says, shown below is a prism. So we've got this L-shaped prism, and we've been asked to work out the volume of the prism. So we want to find the volume of this L-shaped prism. So we want to find the area of the cross section, so this L shape, and then we'll times it by the length of the prism, which is 4 meters in this case. So we want to find the area of this cross section here, this L shape. Okay, so we want to find the area of this L shape. So what I'm going to do is I'm going to cut this L shape into 2 rectangles. So I'm going to cut it down this way. So we've got this rectangle here and this rectangle here, and if we find the area of both of these rectangles, we can add them together to get the area of the cross section of the prism. So let's start off with this rectangle here. So we've got this length to be 6 meters. That means that this length here is 6 meters. That's 6. And if this length is 9 meters, that means that this length is 9 meters. That's 9 meters there. And 9 times 6 is equal to 54 meters squared. So the area of this rectangle is 54 meters squared. Now let's find the area of this rectangle. So if this length is 3 meters, that means that that length is 3 meters. And if we do 3 times 10, that's equal to 30. So 30 meters squared. So that means the area of the front of this prism would be 30 plus 54. So 30 plus 54 is equal to 84 meters squared. So that's the area of the front of this shape, the area of this L shape, which is the cross section of the prism. Now we just need to multiply the area of that cross section, that 84 meters squared, by the length of the prism, which is 4. So the volume would be equal to the cross sectional area, which is 84 meters squared, multiplied by the length of the prism, which is 4. And if we do 84 times 4, that'll give us the volume of the prism. So let's do 84 multiplied by 4. So 4 times 4 is 16. Put a 6 down and carry a 1. 4 times 8 is equal to 32, plus 1 is 33. So that means the volume of this prism would be 336 meters cubed. So that's the volume of this prism. Okay, let's have a look at our next question, question number 8. And so question number 8 says, shown below is a triangular prism. So we've got this triangular prism. So we've got this triangular cross section here. So this is the cross section of the prism, this triangle. And then the length of the prism would be 10 centimeters. So we've been asked to find the volume of this triangular prism. So we want to find the area of this cross section, the triangle. And once we find the area of the cross section, we can then multiply by the length of the prism, which is 10 centimeters. So let's find the area of this triangle. To find the area of a triangle, the area of a triangle is equal to half the base times the height. So we're going to do a half of the base times the height, so it's going to be 7 times 3. Now remember, you could do half of 7, which is 3.5, and then times it by 3. Or you could do half of 3, which is 1.5, and then times that by 7. But I think a much easier approach for this question would be to do 7 times 3, which is 21, and then half it. So 7 times 3 is 21, so we're going to do half of 21, and half of 21 is 10.5 centimeters squared. So that's the area of that triangle, 10.5 centimeters squared. Now to find the volume of this prism, we need to get the cross-sectional area, which is 10.5, and we just need to multiply that by the length of the prism, and the length of the prism is 10. So we're going to times that by 10, and 10.5 times 10 would be 105. And then let's remember our units. We're dealing with centimeters here, so that'll be centimeters cubed. So the volume of that triangular prism would be 105 centimeters cubed, and that's it. Okay, let's have a look at our next question, question number 9. Okay, so question number 9, it's a calculator question, and we're told shown below is a triangular prism. So here's another triangular prism, and we've been asked to find the volume of this triangular prism. So again, we want to find the area of the cross section. So we've got this triangle, that's the cross section of the prism, that triangle there, and we want to find the area of that triangle, and then we'll times it by the length of the prism, which in this case would be 21.5. So let's find the area of the triangle. So the area of a triangle is half the base times the height, so half the base times the height. We could do half of the base, which would be half of 6.8 would be 3.4. So you could do 3.4 times 8.5, or you could half the 8.5 and then times it by 6.8. But in this case, I'm going to do a half off, and I'm just going to times them together. So 8.5 multiplied by 6.8. So I'm going to times them together, and then I'll half it. So we're going to do a half off, and then on my calculator, I can just type in 6.8 multiplied by 8.5, and that's equal to 57.8. And then I'm just going to divide that by 2. So divided by 2 is equal to 28.9. So 28.9 centimeters squared. So that's the area of that triangle, which is the cross section of that prism. Now we just need to times it by the length. So the volume of the prism will be equal to 28.9 multiplied by the length of the prism, which is 21.5. So that's the area of the cross section multiplied by the length. So 28.9 multiplied by 21.5 is equal to 621.35, and then we're dealing with centimeters here, so that'll be centimeters cubed. That's the volume of that prism. So just to recap, we find the area of the cross section, which was 28.9, and then we multiply that cross sectional area by the length of the prism, which is 21.5, and then we've got the volume, and that's it. So we just find the area of the triangle and times by how long the prism was. Okay, let's have a look at our next question, question number 10. Okay, so question number 10. This time we've got a trapezoid prism. So we've got this trapezium, which is the cross-section of the prism. So if you chopped it down vertically, you'd always get that trapezium. So we've got this trapezium, and the length of the prism is 12 centimeters. And we've been asked to find the volume of the prism. So we want to find the area of the cross-section. So we want to find the area of this trapezium. And then once we find the area of the trapezium, we can then just times it by 12 because that's the length of the prism. So let's find the area of the trapezium. So the area of a trapezium is a half a plus b times the height. So what that means is we do a half of a plus b, that's the two parallel sides. So we're going to do 6 plus 8. Well, then half that, and then times it by the height, the distance between them, which is 5. So we're going to do a half of a plus b, so it's going to be 6 plus 8, so 6 plus 8, the two parallel sides, and then we're going to times that by the height of the trapezium, which in this case is 5, so times by 5. So if we work this out, half of, and as a calculator question, you could just type that into the calculator and get the answer if you wanted to straight away. 6 plus 8 is equal to 14, half of that is 7, and then we're going to times by 5, and 7 times 5 is 35. So that means the area of that trapezium is 35 centimeters squared. And it's very important whenever you're doing these questions, you know how to find the area of a triangle, which we looked at previously, half the base times the height, but also a trapezium, which is a half a plus b, and then times by h, the distance between them, that perpendicular height. And now we've found the area of the cross-section. Now we just need to multiply by the length of the prism. So the volume would be equal to the cross-sectional area, which is 35, multiplied by the length of the prism, which is 12. And we can just do 35 times 12 on our calculator. So 35 times 12 is equal to 420. And we're dealing with centimeters here, so that'll be centimeters cubed. And that's it. That's the volume of that prism, 420 centimeters cubed. Okay, let's have a look at our next question, question number 11. So question number 11 says, shown below is a prism, so we've got this prism, and the cross-section is a parallelogram. So this is a parallelogram prism, or a prism that has a cross-section of a parallelogram. So as you can see here, if you cut it down vertically, no matter where you cut it, it will be that parallelogram there. So to find the volume of this prism, we want to find the area of this parallelogram. So we've got this parallelogram, we want to find the area of that parallelogram, and then we'll times it by the length of the prism, which in this case is 14. So to find the area of a parallelogram, and that's another shape you need to be able to find the area of, it's just the base times the height. So the length of the base times the height, the distance between the two parallel sides. So in this case, the length of the base would be 9, because it's 9 centimeters in terms of the length of the top of it. So that means the base of it would be 9 centimeters. And then we're going to times it by the perpendicular height. That means the distance between these two parallel lines. So in this case, it would be 4. This 5 we don't actually need to use in this question. So the area of the parallelogram will be the base times the height. The base of the parallelogram is 9, multiplied by the height of the parallelogram, which is the distance between the two parallel sides, which is 4. And 9 times 4 is 36 centimeters squared. And we don't need to use that 5 centimeters, okay? So that's it, we just do 9 times 4. So that's the area of the parallelogram, 36 centimeters squared. We want to find the volume of this prism, so we're going to do the volume, which is the cross-sectional area, which is 36, multiplied by the length of the prism, which is 14. And if we do 36 times 14, that'll give us the volume of this prism. And 36 times 14 is equal to 504. And then the units would be centimeters cubed. And that's it. So that's the volume of that prism, 504 centimeters cubed. Okay, let's look at our next question, question number 12. So question number 12 says, the solid triangular prism shown below is made from metal. So we've got this metal triangular prism, and we've got the triangle, which is the cross section here, and the base of the triangle has a length of 40 centimeters. The height of the triangle is 22 centimeters, and the length of the prism is 65 centimeters. And we're told that this prism is melted down, and the metal is used to make solid cubes, and each with a side length of 3 centimeters. So we want to make lots of these cubes that have got a side length of 3 centimeters. And the question says how many cubes can be made. So how many of these cubes can be made from the metal that comes from this shape here? So if we find the volume of this triangular prism, that'll be how much metal there would be. Then we could find the volume of the cube and see how much of the metal is needed for each cube. And then we could just divide it, the total volume of this shape, by the volume of the cube to see how many cubes can be made. So let's do that. So let's find the volume of this prism. So to find the volume of the prism, we're going to need to find the area of this triangle to begin with. So we want to find the area of that cross section, and then we'll times it by the length of the prism, which is 65. So the area of the cross section would be, it's a triangle, so half the base times the height. So we're going to do a half the base times the height. Well, we could do a half of 40, which is 20, and then times that by 22. That'd be quite straightforward. It's a calculator question, actually. So you can actually just type this in, a half of 40 times 22, or you could do 40 times 22, get that answer, and then divide by 2. And when you do that, you'd get an answer of 40 times 22 is equal to 880, divided by 2 is equal to 440 centimeters squared. So that's the area of the cross section. Now we want to find the volume of this prism, so we now need to times that cross sectional area by the length. So we need to times by how long the prism is. So the volume will be equal to 440 multiplied by 65. And when we times by 65, we get a volume of, the volume of that prism is 28,600 centimeters cubed. So that's the volume of that triangular prism. And then we're told that that prism is melted down and the metal is used to make solid cubes. So altogether, the volume of that metal would be 28,600 centimeters cubed. That's how much metal there would be. And then each of the cubes it's made has got a side length of 3 centimeters. So let's find the volume of this cube. The volume of the cube would be 3 times 3 times 3. So 3 times 3 times 3. And 3 times 3 is 9, times 3 is 27, so that's 27 centimeters cubed. So each of these little cubes has got a volume of 27 centimeters cubed. So if we divide the total amount of metal, which would be 28,600, by the volume of each cube, which is 27, we can then see how many cubes can be made. So let's do that. So let's take the volume of metal that we've got, 28,600 centimeters cubed of metal, divide that by 27, how much metal is needed for one cube. That tells how many cubes we can make. So that's equal to, and it's a decimal number, 1059.259 and so on. Now obviously here if we look at this, we can't make 1060 cubes. We can only actually make, in terms of complete cubes, 1059. So 1059 cubes can be made, and there'll be a little bit of metal left over, and that's it. Okay, let's have a look at our next question, question number 13. So question number 13, we've got this prism, and we've been asked to find the volume of the prism. So if we have a look at this prism, it's a trapezoid prism. We've got this trapezium at the front of the prism. So we've got this trapezium at the front of the prism. Now some people might look at this and actually cut it into a rectangle and a triangle. That would be fine as well. But I think if I was doing this question, I would actually just find the area of this trapezium. But you could actually use either approach. You could cut it into a rectangle and a triangle and then add them together to get the area of the front of the prism and then times it by 20. So here we've got our trapezoid prism. The cross section of the prism is this trapezium here, and it's the trapezium. If you turn your head sideways, you might actually look at it in terms of the trapezium that we've seen earlier in this booklet. But we've got this trapezium here, and then in terms of the length of the prism, that would be 20 centimeters. So we need to find the area of this trapezium and then times it by 20. So let's find the area of this trapezium. Remember, the area of a trapezium is equal to half a plus b times h, where a and b are the two parallel sides. So in this case, that would be 24 would be one of them. In terms of this one here, that would be equal to 16. So here we've got our two parallel sides shown with the two little arrows, and the length of those two parallel sides would be 24 and 16. And h is the perpendicular distance between them. So that straight distance between those two parallel sides would be 6 centimeters. That 10 centimeters there, that's a diagonal length. We don't actually need that. It's a bit of a red herring here in this question. So in terms of finding the area of this trapezium, we're going to do a half, and then we're going to do a plus b, so it's going to be 24 plus 16, and then we're going to times that by h, the distance between them, that perpendicular distance between them, which is 6. And when we do that, we get, well, 24 plus 16 is 40, a half of that would be 20, and times by 6 would be 120 centimeters squared, 120 centimeters squared. So that's the area of that trapezium, 120 centimeters squared. So that's the area of the cross section. Now to find the volume of the shape, we just need to do the cross-sectional area, which is 120, multiplied by the length of the prism. And as you can see here, that's 20. And if we do 120 times 20, that will be the volume of this prism. So 120 multiplied by 20 is equal to 2,400 centimeters cubed. And that's it. So that's the volume of that prism. Okay, let's have a look at our next question, question number 14. So question number 14 says, Siobhan's got a solid glass paperweight. So we've got the solid glass paperweight. It's a trapezoid prism. We've got this trapezium at the front, and as you can see, it's a prism. And we're told the density of the glass is 2.5 grams per centimeter cubed. So every single centimeter cubed of this glass paperweight has got a mass of 2.5 grams. And we've been asked to work out the mass of the paperweight, include suitable units. So we want to find out how heavy this paperweight is. We want to find its mass. So if we want to find the mass of this paperweight, we're going to need to find the volume of the paperweight. And then once we know the volume of the paperweight, we know that every single centimeter cubed will have a mass of 2.5 grams. So we can just times the volume by 2.5, the density, and that'll give you the mass. So let's work that out. So let's find the area of that cross section. And we have got this trapezium at the front of the prism here. And if we find the area of that trapezium, we can then times it by the length of the prism, which is 10. So the area of a trapezium is equal to half a plus b times h, where a and b are the two parallel sides, so in this case 2 and 5, and h is the distance between them, that perpendicular distance between them, which is 4. So we're going to do a half of a plus b, so that's 2 plus 5, multiplied by h, which in this case is 4. That's a calculator question, so that's quite nice. You can just do 2 plus 5 divided by 2 times by 4 is equal to 14. Or you could type it in like this, and you get that's equal to 14, and that will be centimetres squared. So the area for that cross section would be 14 centimetres squared. So that's the area of the front of that prism. Now to find the volume of the prism, we just need to times it by its length, which is 10. So the volume would be equal to the cross-sectional area, which is 14, times the length, which is 10. And 14 times 10 is 140 centimetres cubed. So that's the volume of the paperweight. Now we were asked to find the mass of the paperweight. Remember that every single centimetre cubed has got a mass of 2.5 grams. That's what this density means. The density of the glass is 2.5 grams per centimetre cubed. So every centimetre cubed has got a mass of 2.5 grams. So if we take the 140, how many centimetre cubes there are, and times them by 2.5, so if we do the volume times the density, we'll get the mass. So 140 multiplied by 140 multiplied by 2.5 is equal to 350, and that would be in grams. So that means the mass of the paperweight is 350 grams, and that's it. So Siobhan's paperweight has got a mass of 350 grams. Okay, let's look at our next question, question number 15. Okay, so question number 15. Question number 15 says, shown below is a triangular prism. So we've got this triangular prism. It's got a height of 14 centimetres, a length of 20 centimetres, and we don't actually know x, which is the base of the triangle. And we're told the height of the triangle is 14 centimetres. Yep, the length of the prism is 20 centimetres. We're told the volume of the prism, so we know the volume is equal to 1,232 centimetres cubed. And the question says, work out the length of the base of the triangle. So we want to find x. So we want to find x here, the length of the base. Now we've got the volume. Now what I'm going to do here is, remember, to find the volume of a triangular prism like this, we would get the area of the cross section. So we would get the area of the triangle. And then what we'd do is we'd times by the length of the prism to get the volume. So if we work backwards here and we take the volume and divide it by the length, so if we take the volume and divide that by 20, the length of the prism, what that will tell us would be the area of this triangle. So let's do 1,232 divided by 20, and that's equal to 61.6. So that means the area of that triangle will be 61.6 centimetres squared. So if you divide the volume by the length of the prism, you'll get the cross-sectional area. So if we do 1,232 divided by 20, we get the area of this triangle. Now this is fantastic. We've got the area of the triangle, the cross-section, which is 61.6. We know the height of the triangle, and we just need to find the length of the base of the triangle. There's a few different ways we could do this. One approach is to work backwards, because remember, if we want to find the area of the triangle, we do the base times the height, and then half it, and that's equal to 61.6. So if we take 61.6 and we work backwards, so let's double it, so let's times by 2. So 61.6 times 2 is equal to 123.2. We now know what these two numbers times together to be. Then we can just divide it by 14. So if we do 123.2 divided by 14, that'll be equal to the base of the triangle. So if we divide by 14, that's equal to 8.8. So 8.8. So that means the x is equal to 8.8 centimetres. So we just worked backwards there. We knew the area of the triangle is found by doing the base times the height and then halving it. So we took the area, we doubled it, and divided by the height, and that gave us the base. So that was one approach. I just want to change colour of ink there to show you there's another approach. And that is, obviously, if we know that the area of a triangle is half the base times the height, we can make a little equation where we knew the area of the triangle was 61.6. That's equal to half of the base times the height. So half times the base, which is x, times the height, which is equal to 14. And then you could solve this equation. There's a few different ways you could solve this equation. You could get rid of the half by timesing both sides by 2, and then get rid of the 14 by dividing both sides by 14. And again, you'll get x equal to 8.8. What I probably would do is, if I was given this equation, I would do a half times 14, which is 7. So I get 61.6 is equal to 7 times x, and then divide both sides by 7. And again, you'd get the x is equal to 8.8. So that means the length of the base of the triangle is 8.8 centimetres. So that's it. So the length of the base of the triangle is 8.8 centimetres. Okay, let's have a look at our next question, question number 16. So question number 16 says, shown below is a solid triangular prism. So we've got the solid triangular prism, and the prism is made from titanium. So this is a solid titanium triangular prism. And we're told that the mass of the prism is 9.45 kilograms. So that's how heavy it is. And we're told the density of the titanium is 4.5 grams per centimetre cubed. So every single centimetre cubed of titanium has got a mass of 4.5 grams. And we've been asked to find the length of the prism. So we want to find x, the length of the prism. Okay, so what I'm going to do in this question is, first of all, I'm going to have a look here at the fact that the mass of the prism is 9.45 kilograms, and I'm going to change that into grams to begin with, because the density is in grams, so I'm going to change the mass into grams as well. So there's 1,000 grams in a kilogram, so we'll times this by 1,000, so that'll be 9,450 grams. So that's the mass of the prism. Now, if we know the density of the titanium, that every single centimetre cubed has got a mass of 4.5 grams, if we divide the total mass by 4.5, that'll tell us how many centimetres cubed there'd be. So in other words, the volume. If you divide the mass by the density, you get the volume. So that means that the volume is equal to the mass divided by the density. If you divide 9,450 by 4.5, you'll see how many centimetres cubed there'd be. So if we do 9,450 divided by 4.5, that's equal to 2,100. So that means the volume of this prism is 2,100 centimetres cubed. So that's fantastic. We now know the volume of the prism. We can then work out the area of the cross section. So we can find the area of this triangle here. And once we find the area of this triangle, we can then work out the length of the prism. So let's do that. So let's find the area of the triangle. Remember, the area of the triangle is equal to half the base times the height. So we're going to do half the base, which is 6, times 9, which is 54. Or you could do a half of 12 times 9, and 12 times 9 is 108, and divided by 2 would be 54. So 54 centimetres squared. So that's the area of that triangle, 54 centimetres squared. Now, this is fantastic, because if we divide the volume by the cross-sectional area, we'll find the length. So let's do that. So let's do 2,100 divided by 54, and that'll tell us x, the length of this prism. So that's equal to, x would be equal to 2,100 divided by 54 is equal to 38.888 and so on centimetres. So that's fantastic. We've found the length of the prism. The length of the prism is 38.888 and so on centimetres, or if we round that to 2 decimal places, that'll be 38.89 centimetres to 2 decimal places. And that's it. So just to recap in this question, we divided the total mass. We changed the mass into grams. We divided it by the density to find the volume, which was 2,100. We then found the cross-sectional area, which was 54. And we divided the volume by the cross-sectional area, and that gave us the length of the prism. And that's it. Okay, let's have a look at our last question. Question number 17. So question number 17 says, shown below is a swimming pool that is full of water. So this swimming pool is full of water, and it's a prism, and the cross-section of the swimming pool is a trapezium. So you can see this cross-section here. And then we're told, Kavon begins to empty the swimming pool at a constant rate, and the level of water goes down by 3 centimetres in the first 15 minutes. And the question says, how long does it take in total to empty the swimming pool? Okay, so to begin, the first thing we know is that the swimming pool is full of water at the very beginning, so it's full of water. So what I'm going to do is I'm going to actually work out the volume of the pool to begin with. So I'm going to find the area of this trapezium, and then I'm going to times it by 14. So to find the area of the trapezium, we do it, the area is equal to a half of a plus b multiplied by h. So that's the area for trapezium. We've looked at that in previous questions. In terms of a and b, they're the two parallel sides. So that would be the 1.2 metres and the 2 metres here. So obviously if that's 2 metres, that would be 2 metres. So we've got A and B, and h is the distance between those two parallel lines. So if we look here, that's equal to 25 metres, so that means that that distance there would be 25 metres as well. So that means that the area of this trapezium would be a half, then in brackets a plus b, so that would be 1.2 plus 2, so 1.2 plus 2, and then multiplied by h, the distance between them, which would be 25. So now let's work this out. As a calculator question, so that's quite nice. And that's equal to 40 metres squared. So the area of the cross-section is 40 square metres. And then to find the volume of the pool, we now need to times that cross-sectional area, that 40, by the length of the prism, which would be 14, so times by 14. And 40 multiplied by 14 is equal to 560. So 560 metres cubed. So that's the total volume of the swimming pool, and we know that it's full of water to begin with. Okay, and then if we go down, we're then told that Kavon begins to empty the swimming pool at a constant rate. So the water is coming out at a constant rate, and the level of water goes down by 3 centimetres in the first 15 minutes. So here, obviously, if we look at the swimming pool, the shallow end of the pool has got a depth of 1.2 metres. The deep end of the pool has got a depth of 2 metres. But in the first 15 minutes, the water only goes down by 3 centimetres. So it just comes down a little bit. And actually, if we consider that, that would be a cuboid. Because actually, if it comes down, I'm actually going to sketch this in blue here. So what we'd find is that level of water in the pool would decrease by 3 centimeters in the first 15 minutes. So if we actually work out how much water's left the pool, if we actually work out the volume of this cuboid, so the volume of the space in the pool above the level of the water, then that'll be how much water's left the pool. In terms of that cuboid, it would have a length of 25 meters, a width of 14 meters, and a height of 0.03 meters, because that's how much the level of water has decreased by in the pool, 0.3 meters, which is 3 centimeters. So if we do 14 times 25 times 0.03, that'll tell us the volume of water that's left the pool in the first 15 minutes. So let's do that. So let's work out the decrease. So that would be 25 multiplied by 14 multiplied by 0.03. And when we work that out, let's see what we get. So 25 times 14 times 0.03 is equal to 10.5. So 10.5 meters cubed of water has left the pool in the first 15 minutes. So that's fantastic. We now know the rate at which the water is leaving the pool. It's leaving it at a rate of 15.5 meters cubed every 15 minutes. So what I'm now going to do is I'm now going to divide that 10.5 meters cubed by 15, because that'll tell us how much water leaves the pool every single minute. So let's do that. So let's take 10.5 and divide that by 15, and that'll tell us how much water leaves the pool every minute. So 10.5 divided by 15 is equal to 0.7. So 0.7 meters cubed of water leaves the pool each minute. So each minute. So that's fantastic, because we now know how much water is in the pool to begin with, 560 meters cubed worth of water. We know how much it's decreasing by each minute, 0.7 meters cubed. If we do 560 divided by 0.7, that'll tell us how many minutes it takes for the water to leave the pool. So 560 divided by 0.7 is equal to 800. So it takes 800 minutes. And actually, if we go down to the answer section, it's actually got here hours and minutes, so we need to change 800 minutes into hours and minutes. So 13 hours, 13 times 60 is equal to 780. So that would be 13 hours. So 13 hours is 780 minutes, and there'll be 20 minutes left over. So that'll be 13 hours and 20 minutes, and that's how long it would take for the water to empty the pool. So that's how long it take Yvonne to empty the swim pool, and that's it. And that's it. So these have been the video solutions to the Corbettmaths practice questions on the volume of a prism. If you need any extra help on finding the volume of a prism, if you go to Corbettmaths and go to the videos and worksheet section and go to video number 356, there's a dedicated video tutorial there on finding the volume of a prism. Alternatively, you can scan this QR code. But in this video, we've focused on the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. If you know anyone that needs any extra help with their maths, please also recommend Corbettmaths to them as well, because it'll be really useful for them to hopefully use the resources as well. So thanks very much and all the best. Cheers. Bye.